Hello and welcome. In this short demonstration I'm going to illustrate how RaptorQ can be used to compensate for packet losses in challenging network conditions. A video stream, such as the one that I'm showing right here, can be completely garbled when packets are lost on the network, resulting in a video that looks more like this. RaptorQ can be used to transmit a flawless video under such conditions. In this demo I'm using the CodornicesRq implementation of RaptorQ. Please refer to our website www.CodornicesRq.info for further information such as licensing, evaluation kits, and so on. Okay, let's get to it. What's playing on screen here is a short movie called Tears of Steel, a freely available movie that we're using here just for illustration purposes. The average bitrate of this video is 6 megabits per second. The demo you see here has two components, a UDP sender and a UDP receiver. The sender reads the video from disk, chops it up into packets, and transmits those packets over UDP. The receiver receives the packets, reassembles them into a video stream, and hands it off to the video player, which displays it on the screen here. For the purpose of this demo, sender and receiver reside both on the same machine, and so the network conditions are perfect. You can see the video is playing flawlessly. However, packet loss will be an issue in realistic networks. Let me demonstrate this by increasing the packet loss probability to 0.1%, say. You can see the video is still playing, but there are now glitches here and there, which are somewhat disturbing. The quality is certainly no longer great. Things get worse if we increase the packet loss probability. Let's see what happens if we increase the packet loss probability by an order of magnitude to 1%. It's now bad enough that you wouldn't want to watch it. Certainly not for entertainment, and also not for critical work. Let's bump the packet loss probability by another factor of 10 to 10%. The video is now complete gibberish. You can't see what's happening anymore. Okay, so that's obviously pretty bad news if you want to stream video in a context where network conditions are less than ideal. There is a solution, however. A RaptorQ code can be applied to the stream. What this means is that the sender will augment the stream with extra packets, which we call the RaptorQ repair packets. The receiver can then use those repair packets to compensate for missing packets with the decoder. That way, the receiver can reconstruct a perfect stream, even when a large number of packets is lost on the network. Let's enable RaptorQ on our example video stream. As we can see, the video snaps back into view and is now perfectly good again, despite the fact that there are significant packet losses on the network. In this example, the repair fraction is 25%, which means that 25% of the packets that the sender sends are repair packets. With that much repair, the stream can sustain much higher packet loss rates than 10% before it breaks down. Let me set the loss rate to 20% and see what happens. It's obviously still working fine, even with 20%. At some point, it will break down, however. Let me bump the loss probability to 45%. Now it's again broken. At this point, there is simply not enough data arriving at the receiver to reconstruct the stream. I can, however, bump up the repair fraction as well. Let's put it to 50%. As you can see, we get back our video playing perfectly again. One last point. You may wonder, why use UDP? Most streaming over internet uses TCP nowadays, but TCP only works well when the network conditions are good, which is the case for most wired networks. While it does guarantee reliable delivery even in challenging networks, the transfer rate will be terrible and fluctuate a lot. It will result in video playback that constantly pauses or stutters, or it may simply not even play at all. Anyways, that's all for today. Again, please visit www.CodornicesRq.info for further information on our RaptorQ implementation. Thanks for watching. I hope you enjoyed it. Bye-bye.